Okay, so just to tell you, all of the lessons, so I record the blue screen essentially and anything over there. Anything that is there, I've put up in YouTube as an unlisted link, but I've put the links. If you go into our class notebook, in the content section, at the bottom it should come as it's added, but 09 there's a redox theory section, and then there's a redox page that comes from that, and in there are all the lesson links to date, so it'll tell you what the content is, and you can click on them and you can rewatch them. So if you're having issues, I suggest you try that, but they are there for everybody, and there's a couple of more different links in there as well. So we're going to start going through now what the Chemistry Live questions. So I have already posted an assignment, and in that assignment there are, I think, 5 Chemistry Live questions, and maybe the same again from the workbook in terms of the photos. We're going to try go through a chunk of these today, and whatever is left over you need to go through and make sure you're happy. You have to upload the photos, please, because I can't give you any feedback if you just put a JPEG as an attachment. So off you go. 14.3 if you have your textbook. And I'll start putting up the solutions slowly. Please ask questions. Do it come? Huh? Yeah. Do. Okay. And it's not connecting, so we'll get the kids to press the button. Okay. I'll do it off my phone, like Teams. Okay, apologies. I'm working off my phone's hotspot now because our whole internet has died. So can you still see my share screen, or did that disappear?
No, we can see it.
Okay, so that stayed because my internet has gone completely in our house now, so I'm working off my own hotspot. Okay, I'm going to start showing you some of the solutions. So the I2, because it's an element, has a 0. For the KCl, the chlorine is -1. Potassium, because it's group 1, will be +1. For the MgF,
Miss,
yeah.
I can't see your screen.
Okay, so I'm not sharing it. Okay, give me 1 second now, Jim, to make all the heads
Thanks.
small. Thank you. So did it freeze on the share?
No, now I can see it.
Okay. Alrighty, so lost my own pen now. So for the MgF2, it goes, the rule would be fluorine is always going to be -1 because it's the most electronegative thing. I have 2 of them. -2 means magnesium is +2, but I can also get magnesium, because it's group 2, will always be +2. H2SO4. So for H2SO4, oxygen is your way in. It's -2. I have 4 of them, -8. It must mean the other side must in total be +8. Hydrogen will always be +1. I have 2 of them, +2, which leaves me +6 for sulfur. And I'll do the last one. So this is the peroxide again. So this is the exception. Oxygen will be the +1. I have 2 of them, +2. It makes my 2 oxygen have to be -2, and each oxygen worth -1. So this is a rule, as is this one and these guys here. They are your group charge is your oxidation state or your oxidation number. So for calcium carbonate, oxygen -2, 3 of them -6. The other side in total must be +6. Calcium, because it's group 2, will always be +2, which must make carbon in this instance +4. Iron, because it's an element, will be 0.
Miss,
Yeah.
you know how group 1 is positive and then group 2 is like +2? Does that work with all the groups going up the table?
No, it doesn't. Because when you get to the elements that are on the right hand side that we would usually have, halogens is -1, the oxygen is -2, nitrogen, that group would be -3. That doesn't necessarily hold when you're calculating oxidation states.
Okay.
But group 1 and group 2 will always be +1, +2. Have we finished 14.3? I can see quite a lot of heads. Yeah? Okay, I'll go through the rest. So for hydrogen sulfide, your hydrogen is going to be +1. There's 2 of them, +2. It makes the sulfur on the other side -2. For your IO-, you go in through your iodine or through your oxygen. So -2, it must be -1 to have a 1 negative charge left over, which makes the iodine +1. IO2-, again -2, I have 2 of them, is -4. To have 1 negative left over, -3, it makes the iodine in this case +3. For the PCl5, chlorine is -1. I have 5 of them, -5, which makes the phosphorus have to be +5. For the nickel sulfate, oxygen is -2. I have 4 of them, -8. It makes the whole of the other side have to be +8. can't figure this one out directly, so I'm going to use the idea that the sulfate is 2 minus overall, which has to make the nickel positive 2. So that's where I'm getting the positive 2 here. And then the sulfur must be positive 6.
This is not the other way around, because on the table, sulfur is +2. No.
So, no. So if I work out just the SO4 2 minus up here by itself, this would be -2, 4 of them -8 to be left over. I have to have -6. The sulfur has to be positive 6. So only group 1 and group 2 will keep their +1 and +2. Anything on the right hand side of the periodic table can change. The CS2 is sulfur -2. I have 2 of them, -4. Carbon must be +4. For the magnesium hydride, this is one of the rules. Hydrogen will be... Did I do that right? No, I didn't. Hydrogen will be -1. I have 2 of them. They will be -2, and this is +2. Apologies. Is that right? Am I getting confused? Yeah.
For CS2, where do you get that S is -2?
When it is looking like this with just carbon and that there's no oxygen or other negative thing present, then it can act as it does in its group. So it can kind of act like oxygen. It's over here in the nickel sulfate where it's attached to oxygen, which is obviously going to be the -2 portion. But over here, because there's nothing else, then this can act, because it's in the same group as oxygen, it can act like oxygen.
Okay. Okay, thank you.
Okay, and then for the last one of this, it is, you can do it from the sulfate to find out what the sulfur is. So -2, I have 4 of them, -8. To have 2 negative left over, this must be -6, which
Scroll
makes...
down a bit.
So for the sulfate, just looking at the sulfate part, it is -2. I have 4 of them, -8. To leave this 2 neg left over, it has to be -6, which makes the sulfur +6. And then just over here, because I have 2 of them, and overall they're each is 2 negative, then if this is -4, my iron has to be +4, and because I have 2 irons, that is +2. So to work out this last one, I worked out the sulfate ion by itself, and then I just used the overall charge of the sulfate to figure out this right hand side.
Miss,
Yep.
are there not 3 sulfates?
Do
Is that a 2 or a 3?
I can't see in mine. No, there's only one sulfate.
But like Fe2, SO4, 3. As opposed
No,
to
it's
2.
SO4 2 in my book. Now I'm looking at a real small copy of it.
SO4, 3.
It's 3 in mine.
Is it 3 in yours? So I apologize because I'm working off the photocopy on this, and it's a screenshot from Chemistry Live, and they obviously don't want you taking screenshots because it can't, what's the word I'm looking for? It won't, they pixelate it. So FeSO4 3. So just, hold on. So continue with limited access, work out my project, new project, blank screen. So you're telling me it is FeSO4 3 times.
Fe2, SO4, 3.
Times. Okay, so again, we just go back. If sulfate is 2 negative, -2, I have 4 of them, -8. To have this 2 negative left over, this must be -6. This is +6. So I've done the S and the O. Because the sulfate overall is a 2 negative charge overall, and I now have 3 of them, then it's -6 for the thing in the brackets, which must make this side +6. And because there are 2 irons, each iron must be worth +3. Apologies for that. I will make sure I change it. How are we doing on 14.4? Thumbs up, thumbs down, still going. Thumbs up, thumbs up, thumbs up. I've got some shakes. So you guys can keep going. So 14.3, 14.4, 14.5. We'll leave the others catch up for a minute. Where's my phone? I just need to see one note. Gonna pause for share. So in Chem Live, you're going to go all the way up to 14.7. If you're waiting. Okay, I'm going to start going through 14.4. So I think that it's MnSO4, so I'm hoping I'm correct on that. So it wants just the oxidation number of the manganese. So the sulfate is -2 overall. It must mean the manganese is +2. In Mn2O3, oxygen again is -2. I have 3 of them, it's -6. It must mean that the other side is +6, and because there's 2 manganese, it makes each one +3. In MnO2, again, oxygen -2, I have 2 of them, -4. It makes the other side have to be +4. And in the last one, the KMnO4, the potassium will be +1. Oxygen is -2. I have 4 of them, -8. So the whole of the other side must be +8, which must make the Mn here +7.
Miss, how did you work out SO4 in the first one?
So this is coming from knowing your complex ions. So you can do it the very long way if you so wish. But sulfate is a 2 negative charge. So that's, I just did the shortcut. But if you want to do it the long way, it would be, this is -2. I have 4 of them, it's -8. Can you do it? No, I don't think you can actually do it the other way. You have to know that sulfate is 2-. So if you know that sulfate is 2-, you can work out the S. So -2 for 1 oxygen. I have 8 of them, or 4 of them, -8. I need to have 2 negative left over, -6. It must make the sulfur +6. So then if this is +6 and this side is -8, the manganese has got to be +2 because this whole side must be +8. So you do have to know what the complex ion is, Rachel. Okay, so look, I'm going to leave it there. You are going to go up to 14.7 for homework. You can ignore the the Chemistry Live workbook questions. And I will see you for our single on Wednesday morning, and we'll see can we finish working out oxidation states. So as I say, the video for this will be up in a little while, and if you have problems, just send a message and we'll try solve them in real time. Okay? I will put up the solutions for the questions that we've just done this morning as well. I'll attach them onto the assignment post. Are we as happy as we can be?